Lecture number 7, and in this lecture we'll discuss the special integrals, which is a very important topic. In this we have 9 special integrals which will be used in the two exercises, that is 7.4 and 7.7. Now in question number, these are 9 special integral which is of the form 1 upon x square minus a square, 1 upon a square minus x square, 1 upon x square plus a square, 1 upon under root x square minus a square, 1 upon under root a square minus x square, 1 upon under root x square plus a square, and in the numerator under root a square minus x square, under root x square minus a square, and under root x square plus a square with respect to x. 3 of one type, 3 of one type, and 3 of one type. So 1 upon x square minus a square is equal to 1 upon 2a log x minus a upon x plus a plus c, and we are not proving these integrals. Simply you learn these and we'll discuss later on the proof of these integrations. So 1 upon x square minus a square is equal to 1 upon 2a log x minus a upon x plus a. 1 upon a square minus x square is equal to 1 upon 2a log a plus x upon a minus x. See the difference between these two. And these two, we have x square here first and then minus x square. 1 upon x square plus a square is equal to 1 upon a tan inverse x upon a plus c. Now the next 3 is 1 upon under root x square minus a square is log x plus under root x square minus a square. And this is 1 upon under root x square plus a square log x plus this, that is under root x square plus a square. 1 upon under root a square minus x square is sin inverse x upon a plus c. Now under root a square minus x square is under root x square minus a square, and under root x square plus a square. See the comparison between these three. It is x by 2, x by 2, x by 2 multiply by these three. You learn like this. In all the three we have a square upon 2, a square upon 2, a square upon 2, and in this we have this, this, and this. See it very carefully. In minus sign it here when we have under root x square minus a square. So this is the 9 special integral. You make your own method to learn these formulas, which is very important. This is the long answer, x by 2, x by 2, all 3 multiply by these individually. Then we have all a square by 2, x square to all 3 plus minus plus here, plus minus plus here. In this under root a square minus x square, you have to use this. In under root x square plus a square, under root x square minus a square, you have to use this, log this here. And in under root x square plus a square, we use this, log x plus this. So you can compare these formulas and learn. So these are 9 special integrals, and the exercise based on this, exercise 7.4, is based on first 6 integrations, special integrals. Now in question number 1, you are not having a direct special integral. It will be after letting something by substituting. You see in the numerator we have 3x square, so you can let x cube is equal to t, like this. So dt upon dx will be equal to 3x square. Replace the value of dx and the value of x cube as t, so it will become this. So dt upon t square plus 1, which is a special integral of 1 upon x square plus a square, or it is a simple integration of tan inverse t. See it. Replace the value of t, which is x cube. So it is an easy question. Now it is a direct special integral 1 upon under root a square plus x square. Yeah, 1 upon under root x square plus a square. You should learn that while using the special integrals, the coefficient of x square should always equal to 1. So I am making the coefficient of x square as 1 by taking 4 common, so it will become 2 outside the integral. Here will become 1 upon 4. For that I have written 1 upon 2 whole square. So it become an integration of 1 upon under root x square plus a square. 1 upon under root x square plus a square is log x plus under root x square plus a square. You take your own time to learn these formulas, and then after that you start this exercise. 1 upon under root x square plus a square is log x plus under root x square plus a square. You simplify this, it will become 4x square plus 1 upon 4. Outside the integration will become 2, and we add with this 2, it will become 2x, and this 2 will go to this constant. The constant into 2 will be constant. If you take this on division of log this minus log 2, and log 2 is constant. When you add this constant to a constant, it will become a constant. So that is why it will become like this. In question number 3 also, you have to let 2 minus x is equal to t. So dt upon dx will be equal to minus dt. So replace t, replace 1 as it is. In place of dx is equal to minus dt, and it will become an integration, special integral of 1 upon under root x square plus a square, which is equal to log x plus under root x square plus a square. Replace the value of t, which is 2 minus x and 2 minus x. Now in question number 4, it is a direct special integral, which is 1 upon under root a square minus x square. But make the coefficient of x square as 1 by taking 25 common. So it will become 1 upon 5 outside. When you take 25 common, it will be 1 upon 5. And 9 upon 25, you write 3 upon 5 whole square. So it becomes a special integral of 1 upon under root a square minus x square, which is equal to sine inverse x upon a. A is 3 by 2. Question number 5, it is clearly seen that you have to let x square is equal to t because we have x here. When you have done the exercise second by integration by substitution, you will easily tell what terms you have to let. So x square is equal to t, so dt upon dx will be equal to 2x, so x will be cancelled out when you put the value of dx. So dt upon 2x, x will be cancelled out, so it will become dt upon a square plus x square, but you have to make the coefficient of x square as t, or t square is equal to 1. Make the coefficient of t square 1 by taking 2 common, so it will become 1 upon 4, and it is 1 upon 2. For 1 upon 2, you write 1 upon under root 2 ka whole square. So it becomes a special integral of 1 upon x square plus a square, which is equal to 1 upon a tan inverse x upon a. 1 upon x square plus a square ka special integral is 1 upon a tan inverse x upon a. A is 1 upon root 2. 2 root t will become, arrange mathematically, replace the value of t, which is equal to x square. In question number 6, is directly seen that in the numerator we have x square, so you let x cube is equal to t. So dt upon dx will be equal to 3x square. Replace the value of dx here. This x square will be cancelled out. In the numerator, denominator we have 1 minus t square, which is a special integral of 1 upon a square minus x square, which is equal to 1 upon 2a log a plus t upon a minus t. The special integral of 1 upon a square minus x square is 1 upon 2a log a plus x upon a minus x. So 1 plus t upon 1 minus t. A is 1, x is t. Replace the value of t, which is x cube. Now we have in question number 7, x minus 1 upon under root x square minus 1. So you break into two integration, that is x upon under root x square minus 1 and 1 upon under root x square minus 1. This is a special integral of 1 upon under root x square minus a square, which is log x plus under root x square minus 1. Here you have to integrate by substitution. By substituting x square minus 1 is equal to t, dt upon dx will be equal to 2x, thus x will be cancelled out, so it will become 1 upon 2 dt upon under root t, like this. See it carefully. Now integrate t ki power minus half, which is t ki power minus half plus 1 upon minus half plus 1, and replace the value of t, which is equal to x square minus 1. Similarly is the question number 8. It is x square upon under root x ki power 6 upon a ki power 6, because we have in the numerator x square. So you let x cube is equal to t. So dt upon dx will be 3x square. That is why this x square will be cancelled out when you replace the value of dx. dt upon 3x square, put it here. For this it will become t square, and for a ki power 6 you write a cube whole square. So that it will become a formula of dx upon under root x square plus a square. So it is a special integral of 1 upon under root x square plus a square, which is equal to log x plus under root x square plus a square. So in place of x we have t, in place of a we have a cube. T square, a cube ka whole square, so a ki power 6, t is t cube, so it becomes t ki power x ki power 6, t is x cube, it is x cube. It's very clear that in this question you have to let 10x equal to t, because the derivative of 10x is equal to sec square, so the sec square will be cancelled out. So let 10x is equal to t. So dt upon dx will be equal to sec square, the sec square will be cancelled out, and you will get 1 upon under root t square plus 2 square. It's the special integral of dt upon x square plus a square, which is log t plus under root t square plus a square, and we know that we have let that 10 is equal to, or t is equal to 10x, t is equal to 10x, which is a special integral. So these are the question based on the special integral, and we are doing the exercise 7.4. Now from this 10 onwards questions, we have we call these types of question as by integrating by making the perfect square to integrate these type of question whenever we have quadratic polynomial in the denominator, either in the square root or not in the square root. We have to make it a perfect square, and then we have to integrate, and then we have the second type of question after this, question number 11, that is linear upon quadratic type questions. And you have this a fixed method to do those types of integration. I'm telling you one, and we'll discuss the remaining question in the next lecture. So question number 2, it is dx upon under root a quadratic polynomial. So how you have to make it a perfect square, be very careful how we have to make it. I will tell you again in the next lecture also. So it is x squared 2x plus 2. So how you have to make it a perfect square when you have a quadratic polynomial, always make the coefficient of x square as 1. In here we have only 1, so you don't have to make that is equal to 1. Now what you have to do after that, you have to adding and subtracting the square of half of the coefficient of x. That is, the coefficient of x is 2 here, and the half of 2 is 1. So you add and subtract the square of 1. That is 1 square minus 1 square. Always add and subtract the square of the half of the coefficient of the linear term of the the coefficient of x. The coefficient of x is 2 here, the half of it is 1. So squaring, adding the square of 1 as 1 square minus 1 square. So it become a square plus b square plus 2ab. It become x plus 1 whole square, and minus 1 square plus 2 is 1, which is equal to 1 square. So it has become a special integral of 1 upon under root x square plus a square. In place of x, we have x plus 1. So the special integral is log x plus under root x square plus a square. So replace the special integral. It is log x plus 1 plus under root x plus 1 ka whole square plus 1 square. Special integral of dx upon under root x square plus a square. We will continue to this in the next lecture. Thank you.